We're live. Feel free to talk.
All right, so we're allowing this to be null for the extension method because technically that's legal, and because we just forward to the constructor, which returns default for null.
Does the compiler actually warn when you invoke this on a nullable string? If you don't make
We
it
have
null?
tests around whether or not the receiver of an extension method is nullable
And then you give me a warning?
or not.
It seems like
we have
this was
tests.
all very much when these APIs were built to allow null for both memory and span.
So again, we deliberately did it to allow null?
right the constructor right allows null. I guess it just seems weird allowing an extension method to also be nullable, because if it was an instance method, we would throw.
Well, not quite. That's a separate question from this. Whether something is string question mark doesn't mean you're explicitly calling it on null, right? We want to allow string question mark regardless of whether you're using a null constant, right? Because you want to allow things that are typed as string question mark to still be called with this without having to bang it.
Sure, but how is it different from any other instance member?
Because these allow null.
No, I'm saying like for any other instance member, you have to check for null, right?
So this doesn't require you to check for null.
Right. What I'm saying is that why would we do this for those, but not for 99% of the rest of the methods? Like, why is it so important to do for those 1%?
Because these are effectively just restated constructors, and the constructors allow null.
Sure, that argument I buy. I don't buy the other argument, because the other argument would basically mean that like the whole design of the feature where you invoke a method on a target doesn't allow when the receiver is statically understood to be nullable.
That's not the argument I'm making. The argument I'm making is the underlying functionality allows null by design. It wouldn't make sense. Even if you wanted to say explicitly passing a null constant wasn't allowed, you still want to allow string question mark.
Well, I mean, if it was a normal instance member,
but it's not.
If it was, it's not an extension member. It's not an instance member because we wanted to break out the generic specialization and stuff from the normal case, and there was a lot of performance reasons for that.
But it's not even just generic specialization. It's this API doesn't make sense on read-only memory of T.
And previously, we also said that null string and string empty should be treated the same. I know it's another reason to just leave it a question.
Yeah, in principle, I have zero problems with this, right? If the argument is that the feature is effectively a constructor call in a convoluted way for technical reasons, then so be it. I think that's a fine argument to make.
Yeah, to me, it just seems confusing that for any other instance member that I would access, if I had a string question mark, I would have to bang it first to say this is definitely not null at this point. But for these extension methods in particular, because of how they behave, we're saying that this can be null without a bang.
And I think that's fine.
I mean, that's no different than like the implicit casts that exist.
It's an extension method. It's not an instance method, and they can behave differently. I don't know. This doesn't seem bad to me.
I mean, to me, like, given that the compiler does the right thing, it seems acceptable. It's just we have to decide per extension method whether nullable makes sense or not. That's all it means.
Yeah, I mean, did a quick test about sharp lab and we do the right thing.
Bit more screen realistic.
One question. The comparers above.
Where is it?
Or like sequence compare to. There was one that was taking a T where T, like a bare T where T was I compare. Or I compare. What was that? Did I miss?
Lower. Sequence.
That one. I comparable.
No. So I thought I saw one that used iComparer, but
Yeah, there was a binary search also.
There.
Yeah.
Yeah.
all
That
right.
one.
So the only question here is we're allowing the comparer to be null or a nullable type.
I think normally we don't accept nullable comparers.
I think it makes sense to not allow null because, like, what would the default be? Don't specify.
Don't we almost always allow nullable compares, and then we just use the equality compare of t.default?
I don't remember honestly. I thought we said the comparers themselves.
My recollection is we pretty much always, for iComparer, we always allow it to be null. For comparison, the delegate, it's generally not allowed to be null.
Is there even a way to express that?
Yeah, where T
Where
not
T
null.
compare question mark.
Where T compare not null would be the way to express where it's not allowed to be nullable.
Yeah.
Here it is allowed to be nullable.
Oh, okay. We allow nullable, right?
Really?
Okay.
And fall back to, as Stephen said, the equality compare.
Sorry about that. Not searching.
What is happening?
Yeah, I'm trying to
me
do
too.
it as well. And binary search in particular is not working.
Nothing is working.
Okay, nothing.
Yeah.
I think we just murdered source.dot.net. Good job, guys.
Create some kind of race, 3 of you or 4 at the same time.
No, actually, in this case, if compare is null, we throw.
Then that should be where T not null.
Possibly it's
Yeah, so I compare T, comma, not null. Right?
Or an attribute disallow null.
You just don't do anything, right?
No. Because
It
we
currently
need to
allows
constrain
it-
it. Yeah, we need to constrain
It's currently just constrained to an interface type. It doesn't mean class or struct. It just means it must implement this interface. So we would want it to be where T not null.
Yeah,
But that would document the code. Would it make sense to just change the code to not throw? Because that's not breaking change to not throw, right? I mean, less breaking than the other way.
I mean, we generally accept that.
Couldn't a constraint make it non-null?
What constraint?
Or T compare is I compare?
No, it's just constrained to an interface. And struct can implement an interface.
Oh, I reset. Okay. For some reason, I cannot, like, the old system runtime that I opened, nothing is nullable in this one. I'm pretty sure something must have been messed up. Okay, do one thing really quick. Data here, what am I doing? So on array, we accept the binary search to be nullable. Sorry, accepted the compare to be nullable.
I'm voting for changing that.
That would certainly make more sense.
I'm fine either way. We just need to do something.
All right. So then we have that. Catch.
I'll add the note that it's not only binary search, anything which takes t, which does it.
Anything that uses t where t compare is that.
What about comparable? Was it the same?
So that's used as the generic constraint two-way span, and I'm assuming spans can contain null just fine.
Well, that one has an explicit t comparable as a parameter. It's not part of span. The first binary search.
Yeah, we probably need to look at that one as well.
Yeah, source.net's completely down though.
I'm not sure if we've had any case of that before.
But shouldn't
Sorry,
be.
what is the concern that's being expressed?
If we should treat the comparable also as the null is acceptable or not. We already established the comparer probably should accept null, but the comparable, I'm not sure.
Well, that's the value you're looking
The
for.
comparable is the instance you're searching for, so it should be allowed to. Oh, I see.
It should be nullable, right? You should be able to look up a null, I suppose.
T.
Assuming that, I guess we just have to look at the binary search and make sure that it behaves correctly for null. It doesn't like throw. It's attempting to compare null.
Yeah, right. But I'm saying, like, I mean, comparable is generally allowed to compare nulls, so like that should work. So.
But the comparable itself, is it nullable or not?
Yes.
You can search for null.
You should be able to search for null, right? Doesn't seem like a completely outrageous.
So we have one comparable method that throws a null, like a binary search that takes a comparable, and one that nulls.
Yeah. So So for t comparable, we are currently throwing if comparable is null.
Seems bad.
So this one throws,
and
this one null refs.
So that does seem by design.
We're throwing in one case and not in another.
And yeah,
but also I don't think this code would compare if you pass no, because you would have to if you cast it then
if you cast or if you provided explicit.
Yeah.
But also the span is typed, so probably the T's.
I see why t comparable is not supposed to be null. It's because we actually call comparable.compare2.
Oh, okay, then that definitely should. We should definitely disallow null.
Yeah, and the second one we should probably have a null check rather than null ref.
Yep.
But
that makes no sense to me. So let's say you have a variable type that's string, right? And you have a read-only span of string, and I call read-only span of string dot binary search variable. Now we crash with another reference if the string is null. That makes no sense whatsoever.
Well, you're passing a comparable, and we're calling comparable.compare2.
yeah, so there's a difference.
There's no choice.
There's a difference between comparable, which is you're using an explicit instance to do the comparison, versus the comparer, which is an external entity which compares two instances.
Yeah, I guess it makes sense. Like you have an instance which.
I mean, if you just pass in a string, you're not going to get that overload, right? You're going to get the first binary search overload.
The one that is t comparable.
The one that is t comparable, right?
But that one also blows up, no?
Feels like this.
No, that won't blow up because that shouldn't blow up.
The first one will null ref.
If you pass in a null string, yes.
Really?
No.
Yeah, because we call comparable.compare2.
No.
So the one that takes a t comparable?
Yeah.
Well, the one that takes a span and a length.
Feels like we should special case it for null and just go completely compare different things compared to this. I don't have strong feelings about this one.
Oh, I see why we don't.
I mean, you could argue and say binary search is hard to do if you don't know what the instance is, right? Because you're supposed to find the closest location for that, but I guess you just have to decide that nulls are at the beginning or nulls are at the end.
Actually, 1 second. The one that got null ref, the public one, I don't think it's supposed to be public.
No,
we don't expose it, right?
It's internal. So it's a public method in an internal
damn
class.
it. Yeah.
But in,
You're
in either
right.
case, the overloads that both go to for both the span and the other one throw if the comparer is null.
Yep.
Because the one that the internal one they forward to ultimately ultimately calls comparable.
I mean, we could technically speak of such for null easily because it's either gonna be in the beginning or the end, so it's probably return either the first or the last one, so it's a simple fix. But
that's a behavior change, right? That's not just
yeah. Well, I don't have a strong opinion.
It's generally not breaking to relax what inputs you take, just to restrict it more.
Well, we'd have to decide whether.
Seems to like if no, then check if first one is null. If not, then check if the last one is null. If not, then -1. But probably we need to establish some pattern of what we, if this is what we actually.
Compare is a weird word the longer I stare at it.
All right, so
somebody just needs to sit down and look at these look at these implementations and rationalize the decisions.
Regardless, it sounds like the attribution is. Oh, I guess we're saying that we're saying that the ones that take a T comparable need to have a disallow null on them, or a comma object null constraint.
Either that or T comparable should be constrained to also not null. One of the two.
Right. That's what I just said. An object constraint.
Not null constraint.
In our build, it's currently object constraint.
Yes.
We'd have to change it later once we get into the pilot.
No.
Okay, if you type that, it's going to fail.
And it looks like the ones that take in iCompare are currently throw as well. But we're saying we might want to relax that, right?
Well, I think that should be a separate thing. We could always relax it to add a question mark in the future. That would be a non-breaking change.
Okay. Yeah, because currently it needs to be not null.
Which is how it's defined.
The only thing is that the T comparable would need to change, no? Or does
no? Both do. Both of them currently throw.
Because we say colon I comparable
and comparable. That's what we're saying. The T comparable either needs to have disallow null or needs to have an object constraint on it.
And I was saying the T comparer as well. T comparer currently throws.
No. T comparer should be allowed to be null. If we null ref there, that's a problem.
No. Currently it throws argument null exception if the comparer is null.
Which
seems like that is extremely inconsistent with everything else we do.
Right.
Yeah, that's what we were.
Yeah, so I was saying we would need to relax that or add the not null constraint here.
Yeah, so either way, the constraints are not in line with what the method does, right? So that's clearly something we need to fix, and then once you have correct annotations, then the separate question is like, do we like the annotations that we see?
Yeah.
But yeah. All right, so it's a good catch. You guys all deserve a raise.
We'll all get null medal in the end.
You get as many nullables as you can carry.
It's either infinite or 1.
For me, it was about 6.
So when I say this, where T colon I comparable.
That's
saying that it is a non-null comparable.
No.
Yeah.
iComparable is an interface. It does not constrain it to whether or not it's a struct type or a class type. So you can't. So it still could be substituted with some question.
It could.
Yeah.
So I guess technically string question mark would implement comparable of string, right?
Yeah.
Question mark, I suppose.
Yeah, you could have a you could have a nullable struct that implements that.
Well, I guess nullable structs are lifted, right? So they would always inherit the same interface.
Constraining to an interface does not tell us whether or not it's a class type or an interface or class type or a struct type.
Can it be the compiler kind of like when it says the struct is non-nullable, then basically it's non-nullable, and any other case it's nullable?
What do you mean?
Basically, if you don't put other question mark, the compiler, my opinion, like the compiler should assume it's non-null, whatever case there is. And if you put the question mark, if the struct is non-nullable, then it's non-nullable because it cannot be null possibly. Any other case, it's nullable.
LDM has argued this point a lot, like a lot.
LDM?
A lot. Language design has argued this point a lot, and.
Yeah, to me, right now, it's not even the question of like what's the correct behavior. I just want to understand what the behavior is.
If you you constrain to an interface, you have not specified whether or not it is a struct or a class, and therefore it could be nullable.
It seems inconsistent with everything else.
Yeah, generics are basically the opposite.
What about actually abstract classes?
Yeah, let's not design the feature right now.
It's generics are basically the opposite. So whereas normal if you have just a string, it's non-null by default. If you've got a generic, an unconstrained generic, or one that's not constrained to struct, then it's considered nullable by default instead, right?
And we don't know whether or not the return, like it depends, right? All inputs must be considered to possibly be null, but by the same token, you can't return something that is known to be null, because what if you'd constrain it to a non-nullable type?
Sorry, I'm having trouble coming up. So if I have class foo of t, where t is comparable of t, right?
Yeah.
And if I have bar that is an comparable of bar, right?
Mm-hmm.
And then I say new foo bar question mark. You're saying that should work?
Yeah.
Okay, it doesn't currently.
Well, so bar isn't comparable. Bar doesn't fulfill that constraint, right? Because bar isn't comparable to bar question mark. Bar is only comparable to bar.
Okay.
Right, but if you have...
But we've already said that we're not going to have... We've already said that t is never going to be comparable of t question mark.
Okay.
Like string is comparable of string, not of string question mark.
But you could, for example, have... you could define bar where bar is comparable of bar question mark.
Yeah,
right?
But we've already said for all of the types in the framework and in our guidelines, we are going to say do not do that.
I mean, sure, we're going to say that, but let's say design...
So that means but hold on. That means that for this case, all the types that might be substituted in here, like string, I'm not clear on how that's going to play with this. Like how would you have a string question mark, as we were just saying, with these constraints?
Yeah, so in practice, basically, you're saying like you will not be able to substitute the built-in types because they don't implement the interface in such a way, right? It still means that, like, you know, from a hardcore standpoint, you would say, well, we don't know who implements the interfaces. You can always create a type that would implement the question mark, and then you can observe null instances, right? But I would agree with you that that seems maybe not that important. But that means, I think the feature then works the way I expect it to work. Okay, that makes more sense to me now. So that basically means every time we see a t:(I) equatable or t:(I) comparable, practically speaking, they are non-null.
Fred, am I wrong? Is that...
I need to go do some tests, but I'm reasonably certain you're wrong. Because an interface constraint does not tell us anything, right? It just tells us that it could be implementing an interface. You
Well,
could
the problem is
substitute struct or a class type.
The problem is that they're
Right, but we're saying different things. If for any type in .NET, any reference type in .NET that implements I-comparable or I-equatable, it's going to be implementing it as T, not as T question mark. And therefore, anything that is constrained to T where T is I comparable of T or I equatable of T could only be the non-nullable version.
Yeah.
Because the nullable version won't implement the nullable.
Yeah, let's separate, like, because there's two kinds of interfaces here, right? There's the referential ones like T:I equatable T, where basically T occurs on both sides, and then there's the one where T only occurs on the left-hand side, right? T:I comparable, right? The non-generic version. So if T only appears on the left-hand side, then the interface constraints tells you nothing. Is that fair?
Still tells you nothing.
That is what Fred is saying.
Yes. And so the fact that the T occurs on the right-hand side means we know that statically speaking, nothing implements I equatable of something nullable. And in practice, nothing implements I comparable of nullable T. So that means, practically speaking, you can't substitute anything. But that's more like a framework design guideline, not a type system thing you can rely on.
Well, I mean, no matter what we did, we would have one of the two problems, right? There's no way we can express where T is I equatable of T or I equatable of T question mark, nor can you implement both I equatable of T and I equatable of T question mark.
No, but you can say where T:I equatable T, comma, non-nullable, right? Or whatever the constraint is.
Sure.
So you can't express the other one, but you can express that you really don't want something that is nullable.
Well, but that's effectively what you get by the fact that everything is I-equatable.
Right. All I'm saying is that, like if the T doesn't occur on the right-hand side and we really don't want it nullable, we would have to add non-nullable as a constraint, right? We can decide that we don't do this for I-equatable and I-comparable because we know that nothing will implement those, but you might as well just add them there for consistency, right? It doesn't hurt. If we really want it to be non-nullable. Like, I'd be fine either way.
But what if you actually wanted to allow nullable? We have no way of doing that.
Yeah, if you really want to allow nullable, then you would just omit the constraint, right? It just wouldn't work for I-comparable and I-equatable because, well, unless we implement both, which we can't, we can't have it.
Well, it wouldn't. If you eliminate the constraint, then the method that needs that constraint to operate to call those methods wouldn't be able to do it.
So which constraint are you talking about? The non-nullable or the interface constraint?
Yeah,
the interface constraint.
Well, you would leave the interface constraint. You would just not have the non-nullable constraint, right?
I might be wrong about this because we're not currently warning if I implement something similar to that method, and then I could just call t.ToString. I'm not currently warning that, which I would have expected us to.
Yeah, it looks like if you constrain I comparable of T to be I comparable of T question mark, then it depends on how you define T comparable in your generic instantiation. So if you say T I comparable of T question mark, then it allows null. But if you do T I comparable of T no question mark, it warns on null. If you constrain the T comparable to be I comparable of T question mark.
I have to say I'm not good with things in my head.
This is a much easier view. And if you remove the question mark from the constraint, then you get all kinds of warnings on both.
Yeah, I think I'm wrong. Sorry, guys.
Yeah, but you have a question mark at a different place, right? You have the question mark basically on the
interface.
The interface, not
which is what I said at the beginning, right? That is constrained to be non-nullable.
I think I'm wrong.
Which for those cases makes sense because we really care about the whole thing, not the actual.
Right. So we're saying that the interface can be null or not, which then constrains the generic type to be non-null or not.
Yeah, but in your case, you have now two generics, which now makes type inference a bitch, right?
Right, but you've got T comparable anyways, so you have to do it. Anytime you've got two, the compiler
because,
never.
yeah, you're right. Like there's a. I always thought there was a.
Yeah, it's the annoying case where the compiler doesn't do generic inference nicely, and
In positive news, Source.dot ends back.
yes.
Yeah.
Fred, just to make sure, so going forward, I understand what you think you weren't quite right about. If I constrain,
You broke up
I
there,
just have
Stephen. I didn't hear you.
Oh, sorry. So if I have an interface IFU, no methods, no, not generic at all, and I have a type that implements IFU, and then I have another type like bar of T where T colon IFU, that necessarily means that T is non-null, right?
Yeah, I don't. I think I was getting it confused with the fact it doesn't tell us whether or not it's a struct or a reference type, but it does tell us whether or not it was null, and I was getting confused with that distinction.
Okay.
So you're saying any generic constraint on interface means non-null unless you put a question mark there?
For
Yes.
interface and reference.
Yeah,
types,
and
right?
interface
to an
or
interface,
that's
yes.
Or
for,
reference
so if we're only
types.
talking about reference types, right? That's true for either a class or an interface. If you say colon something, you're basically, and it doesn't have a question mark, you're saying it is the non-null version of that thing. If you put a question mark, then you're saying it can be null as well.
Okay.
Right, which makes sense if you think about it from the where object. And if you constrain it to object, then it's non-null.
Right, or where class. If you want to be nullable, you have to say class question mark.
Huh?
Or it's a null.
Yeah, but this is for reference types, so.
All right. So I think I don't know more. I have to play more. I think that's. I'm not good with generic substitution in my head.
I'm sure we're going to be resolving this for, this is the next 10-year bug is generics and nullable.
What do you mean the next 10-year bug? That's an ongoing bug since 2005.
The short of it is, I believe these annotations are correct.
Yes, I would agree with that.
Yes.
That is the thing that I just took away from that.
With the exception that it does mean that we're saying you can't ever pass null, and we believe the implementation for most of these matches that.
Actually, I do have a question. Does that mean that the spans that we spans and read-only spans that we passed in here can never contain null?
Well, that's the question: is can T be a nullable of T?
Yeah.
Currently, no.
Well, no. What I mean is
that good?
Currently is in what we shipped in 2.1.2.2. Do those implementations allow T to be null for all of these methods, for any of these methods?
So the binary search already said crashed when you actually have nulls in there, which I would argue is probably not the right behavior.
But binary search, we were speaking about the I comparable, right?
We were speaking
Sure,
about both.
Okay.
But I guess it's kind of depending on how the code path goes, I think on the left-hand side you would also null ref probably.
Yeah.
But
You had a span of string question mark, can you call trim?
Yeah.
Can it meet the constraint of being equatable of itself?
Those seem.
So we for example in trim we have explicit code that allows for the T to be null.
Yeah, we should probably. I think in general, I think we probably want to allow nulls in the spans. I don't know why we would not.
Then what we would have to do is constrain it to I equatable of T. And bracket question mark.
Yeah.
We don't have the ability to do that.
No, that one you can. You just can't put the question mark before the bracket. At least that's what Tanner had in his code, and that seemed to compile.
Wait, sorry. Where do you want to put the question mark?
After the closing bracket.
So where T, I equatable open bracket T, close bracket question mark.
Open bracket T, close bracket. Sorry, where are you looking? Which method are you talking about?
I'm looking at trim right now. One of the trims.
So
can you put your cursor there?
Yeah. So basically, you put the question mark right here where the cursor is.
where T is an I equate, right? But if I then try and instantiate that with, say, a string question mark, won't that fail because string question mark implements I equatable of string, not I equatable of string question mark?
I think there was an issue like that.
That's a good question, probably.
That's the same question I was asking, either to reinforce Steve or we got there from different sides.
Oops.
But I think technically what you're saying is true if someone defines their T to implement I equatable of T question mark.
Yeah.
But it won't work if they've defined their T to be I equatable of T as we have
Everywhere.
Yeah.
everywhere.
And we can't do both, so
Right.
we have to pick one.
No, but should the, like when you implement the interface and you put the question mark, that should allow both, right? Like
No, because anybody who constrains it to the other one.
Because you don't know if they use it for the argument or the return value, right?
Well, the problem was originally we implemented I equatable of T question mark, because that's in line with the with our guidance to accept nullables in the comparisons. But then any method that had a constraint where T colon I equatable T would no longer satisfy.
So it seems like there are two cases.
You
One is
either
where
lose this one or that one. Like you can't have both.
So there are two
satisfied.
cases, like one where the T is used as the input argument, in which case the relaxation should be possible, and one which is used for the return value.
No, because
the
the
relaxation
problem
should
is it's self-referential, right? You have the T occurring on the left-hand side and the right-hand side.
Apparently, I don't
So
get a
depending on how the
warning for
person
that.
voted, you can either not instantiate with
I don't get a
string or not
warning.
instantiate with
Yeah,
string.
yeah, but what I'm saying, maybe the constraining the generic T should work differently for depending on if it is the input or the output. Because in one case you allow relaxation and the other one you don't.
Right, but
There's no way to
I don't
express
think I
that.
equate
Yeah, I know,
this
but that's what I'm saying.
variant.
Yeah,
Or string questions. Sorry.
there's no variance for generics in that level.
It should be something like in
How are you not getting?
question mark on
Oh, you don't have
no
null. You do
question
have
mark or
null.
something like that.
Yeah, but now you're inventing new language features.
Yeah, that's. I think there should be a
How
way
are
to
you not
express it.
getting that? But I am.
All right, so let's just say right now the memory extensions don't aim to accept stands that contain nullability due to the way the generics text giving view a point to rival. I'm sure. All right, so I just
what
wrote
I'm
down the
missing
follow-up
is the
because I don't think we
strings
should
and
design this right now.
annotations.
Otherwise, we're not going to catch the other ones.
Right.
Strings
Yeah.
oblivious.
I suggest we just keep going and take this offline.
God, that would be a horrible hack. But one thing we could do is we could make the constraint on T on string oblivious. And then it would work.
Oh, fuck my life. That means like you surround the implementation with a pragma. That's just
That's
really gorgeous.
horrible. But it would work.
That
Why is string I equatable of string and not I equatable of string question mark?
because anybody who has a constraint today that says where T colon I equatable T no longer binds to it.
You need to
It does bind to it, you just get warning.
But we also,
Sure.
but we then get a warning when we implement equals, which requires you to allow null input.
We have an
We use-
annotation for that.
we-
No,
use the
that'll all be
attributes.
fixed when the attributes come in.
Okay,
Because you express it not with the question mark, but with the attribute.
so maybe this is just a missing attribute.
No, there's no missing attribute that would help.
I mean, one that we need to design to allow something like this to work, because it looks like there's no way that you can properly constrain things such that.
Yeah, let's take this offline and design. Like basically, somebody has to walk through and say what would the syntax have to be, or the semantics have to be on this method, so that you can have null elements and still pass in sensible values for basically both nullable and nullable instantiations of the same type.
I will. Let me put something down and I'll send something out.
Yeah, that seems reasonable. All right, so then let's just. Is there anything else on memory extensions? Are these renames intentional? What happened there? Do you know something?
Which one?
All the renames here?
Oh, those are new methods on 3.0 and it didn't match the.
Oh, so okay, so they're
yeah.
just actually they're real. Okay.
Yeah, I fixed those. Now I get the warning.
Sequence position accepts a nullable
Now
object.
everything makes.
I believe that's true. All right. Man, nullable generics hurt more than I thought it would. Read-only sequence, is that a class or is that it's a structure? I don't know. Yeah, because you take it as in, which kind of
read-only sequence. Read-only sequence of T is a struct.
Okay.
so read-only sequence is but
It's read-only sequence. We have one that's a static class.
Yeah,
that's
yeah, that one. I don't
a
care.
builder of stuff, but apparently it's not even public. So, but read-only.
not even
Well,
instantiated.
I'm just saying it has the word class when I started typing things in
It's
there.
like in namespace.
Yeah.
Position of returns null if the sequence can't be found.
But the value can't be found, yeah.
Okay.
Memory pool can only be a memory pool of something not null.
Yeah, we don't have any attributes, I think, in those ones yet. So, like, the attributes for allow null, all the other ones, that's a secondary pass.
Sorry, what was the question?
Memory pool cannot be a memory pool of string question.
No, it could be.
Yeah, why would you say it couldn't be?
Because it's constrained to idisposable, not idisposable question.
No, that.
But the idisposable constraint doesn't involve the T.
Yeah, it's not constrained.
There's
Right?
no
It's
work.
just implemented.
The moment we make idisposable of T, I will be very confused.
Are you working for RAM manufacturer? You really want to tell us more RAM? Is that your?
I don't know. Do we make RAM yet?
Okay, these are structs. So that's all relatively fine.
Well, there's arrays.
The read-only sequence does reject the null arrays.
Is this segment a class? Probably, right?
Array segment? This is
No, read-only sequence segment. Okay, that's a abstract class. Okay. So the segments cannot be null? I don't know, I'm asking. Like, I mean, for linked lists, you very often have this, like, you know, your low null at the end or something, right? But I guess these ones are always valid, right? Because you have to be able to walk them.
start segment is null or end segment is null throw.
Where's the segment?
This is the guys here, the
really long
sequence segment.
Okay.
I really have to fix the highlighting so we can actually see what are value types or classes. It would totally help.
Only for this meeting.
Oh, I think in general it would help actually. Yeah.
So sequence, you can't ever read a sequence of nullable struct.
But
Why
int
would
question mark is a struct.
Sort of.
It is. Nullable of T where T is struct is itself a struct.
Yes, that is true. Yes.
Pretty sure that constraints to be not null.
I don't think the question mark the same nullable as the other.
I mean, like,
It feels like it should be different. More than
if I write out the word by hand, nullable of int, that is very clearly a struct. The question mark is just language sugar. It should not say that nullable of int is not a struct.
Yeah, I'm pretty sure that the constraint where t colon struct nil will allow you to instantiate the t with nullable whatever.
I mean, a nullability bug here, but like, nullable of int is a struct.
Yeah, I'm pretty sure that's by design because you struct question. And you can't.
Can you put R in the Y?
No, I don't think so. They're just different flags of metadata. They only compose in so many ways.
I didn't know you could do this ref.
Which ref?
Sequence reader extension.
You can also do this in.
Oh, this ref, yeah.
This in I can understand, but like this ref, where did you like the word ref just becomes implicit in the operation?
Yeah, it's like any other method that you call on a struct.
Yeah, it makes it
mutate the
functionally
struct.
the same as an actual instance method where it can mutate the state.
Yeah, I just because that's the first place I've known that the word ref can be implicitly written by the.
That's true, but like there was a big feature in 2.1, I think.
I just didn't know it existed.
I think 7.3, I think it was that. Yeah. No, mind you, the compiler had bad bugs, and sometimes it would not actually pass it by ref. But yeah,
Why is it not in, by the way?
Because it's mutating.
yeah, it advances the reader, right?
Yeah.
Yeah, so you can't use int question as a generic parameter where t is. That's actually an error.
What?
Okay, I object.
Actually, an error. It's not a warning.
If you do
Like with an
which now?
existing compiler, or with only with the nullability feature.
I'm not sure. I'm gonna go check these.
That seems really
Yeah.
weird.
Yeah, the existing compiler 2.9.
So if you do which now?
If you do if you use int question as a generic parameter to a method where t is constrained to a struct, that's existing. You can't do that. So if that's already constrained to struct, then no need to worry about it.
Okay.
But you can't use non-nullable value types. You can't use nullable value types for that.
That makes no sense to me.
This is the way it exists. It
Weird.
behaves today.
That means there's a very special check somewhere that says this was the word nullable.
Yes.
I just don't allow it.
We'll look up the relevant.
Wow. This is a bet that I would have lost big time. Well, learn something new every day. It seems like something we should generally review then, to make sure that that's actually. I guess not really,
It
because
doesn't matter, right?
it's already an existing compiler. Yeah. Never mind.
It is how it is.
How do you allow?
Be a non-nullable value in order to use as a parameter too.
Yeah. How do you allow nullable types when constrained to struct?
Don't.
So it's just something the compiler won't allow ever.
You can't express in the type system, yeah.
But it would find just fine an IL.
and
Probably.
reflection.
Probably.
Seems like the compiler should relax that maybe.
But it is true that at the runtime level, nullable of t is not an arbitrary type. It's very specialized by the runtime, because if you try to box it, it will box a null value. It's not. It will not box the actual nullable of t. So technically speaking, it's not. So it might actually not even bind an IO.
Learn something new every day.
That's generics are hard. I think that's
So can I update
Value
max
type
precision for
constraints.
5.0?
The value type constraint specifies that a type argument used for the type parameter must be a non-nullable value type. What the spec says.
Okay. I wonder what bug they ran into in .NET Framework 2.0 that made them write that down.
Standard format parse in question mark format. We agree that format shouldn't be nullable.
yes, we should. That's a good point.
I thought we said that format can be nullable because that's default format. It's parse that it can't be. Because if you just call ToString, today that passes in null for the format, and that.
I think there are two cases. One is for
Okay.
formatting, for writing, and the other one is for parsing.
Right.
For parsing, I think it's acceptable. That's what I think.
Because all format APIs today take null format because that's the default. That defaults
Let
to
me dig
G
this up
for all the
again, because
integer
I keep
APIs.
confusing this too.
Me too.
I'm pretty sure that's not what we said, but
But I mean, this method in particular, as a static, which is just a parser method on the thing, very explicitly handles null special to return a value. But this one very, very explicitly does take string question mark.
Yeah, as does int.toString, float.toString, etc.
okay. So what we said was try parse shouldn't accept null format strings. On the other hand, we accept null format strings for try parse and ToString. So maybe it should be nullable after all. That's what we said. So for ToString, it seems we kind of made the decision that it actually should be nullable.
For ToString, it should be nullable.
Which means what I wrote yesterday is not wrong. Is wrong.
He's wrong.
Because this one, the format here isn't the format for the parse. The format here is the value to parse. So this is just saying that this parser accepts a null as the string to parse.
Right, because this produces the format string.
Yeah.
Well, yeah, that's a different problem. All right.
Okay, I want to change the API to 5.0 because 99 digits isn't enough for floating point. So, because for the double.epsilon, for example, requires 768 digits to print the full underlying value.
Well, you were right yesterday.
And when we add quad, that's going to be 11,000 digits. So we
99 problems at epsilon 8.1.
yeah. So
Have we ever had a customer bump up against that?
Yeah, that sounds like a
I think Tanner.
it's a thing where we actually support it in our formatting APIs, and we have an artificial limitation preventing it. And there are people who want to get the full underlying value, and most other languages allow it. So we should.
Well, no, but
probably do it.
they can get the full underlying value. They just don't specify an explicit number of digits in a parse format string.
Yeah.
Well, we cap that at round trippable. So no more than 17.
Anyway,
That's a different problem.
different meeting.
Wait, no, sorry, I have a question. You're saying if I give you a double with 700 digits, we have literally no way to parse that today?
No, we'll parse it. We have no way to format it back. We have no way to format the string with the full underlying value. We only can format up to 99 digits. But you can guarantee round tripping at 17 digits. But there's a lot of cases where getting the full underlying value is important, such as when validating the math is being done correctly with complex algorithms.
Such cases, could you just give some pipes directly?
No, that
Do we want to
No,
talk
it's
about this at some later
Yeah.
point in
Yeah.
time?
So, last time I checked, it was not an nullable problem. My brain just threw a null reference exception off.
This was my catch statement.
All these exceptions. Go for it.
Only how to implement a watchdog.
Can you put a bunch of nerds in?
Looks good.
Proceed.
All right. This might take another hour to look at.
Create from pinned array allows you to pass a null array.
Right, because the compiler itself, if you try to pin a null array, just gives you a null pointer.
Okay.
That's actually the right behavior.
Presumably the
Yes, the null array going to the null pointer. I agree with that one. The one where the empty array also goes to the null pointer is I've had to work around a lot.
The target start presumably should have the attribute, right?
I agree with that.
Those should all have the not null if not null, or not null if true. Actually.
So which one?
The second block of yellow.
All targets.
They should be null if not null.
Null if not true, or null if true.
Not null if true.
Not null if true.
This is not confusing at all.
Tongue twisters.
They should
Those
get the
actually-
I'm a try get attribute.
Those actually
Yeah,
are
that would be
constrained
actually
to
good.
be non-nullable to start with. So
Yeah. So the rest looks fine to me as far as I can tell. What does this say? Probably.
Alright, and so nothing in those try get memory managers is going to constrain T to be non-nullable.
T, that's correct. Yes.
Yeah.
T is not constrained to be.
But the memory manager,
The memory
T
manager.
manager is constrained to be non-nullable.
Yes.
My brain.
Presumably is fine.
This might be another interesting one though, where you pass in, where you might have a memory manager of string, right, and you substitute, or you might have a memory manager of string question mark, and you substitute string for T, and then that would be another interesting case of.
Isn't that just a normal case of you're trying to cast something from something with nulls to something without nulls, and it says you can't do that?
Yeah. But that might not be desirable, was my point.
Okay.
But much like the I-comparable and I-equatable of T.
I guess I'm not understanding. If I have a memory manager of string question mark, then I would be operating. Oh, you're saying I have a read-only memory of T, but a memory manager of T question mark?
Exactly. Yes. I can't use them together.
Right, but that would be weird because the memory is tied to the memory manager. So that would mean that you somehow got a read-only memory of T question mark out of the memory manager and then somehow converted it into a non-nullable T and then tried to get the nullable memory manager out of it.
But couldn't you turn a read-only memory of string question mark into a read-only memory of string? Like
With a bang.
Okay, there's no variance that would let that work?
No.
Okay.
What's a string into string question mark? There is a variance. I can't remember if that's co or contra.
Well, like if I had a memory, read-only memory of string question mark, can I assign that to a variable that is read-only memory of string?
Oh, yes, you could.
Right. So then you could have now on your sliced or whatever read-only memory of string, you trying to really operate it as if it were the string question mark that was the original input. So that would be
Yeah. But you're going to have that issue.
Yeah.
I mean, you've effectively cast away the ability to use null, and then if you do that, well, I don't feel too bad about you having to put a bang to get back to it.
Right, but that was the situation where you would end up with a non-nullable read-only memory,
Right.
but you have a nullable manager.
You're right. You could have cast it away.
Yeah.
All right, then. So, then let's close this guy here. If I find a way to do that. All right, so here's the next one.
What are the constraints in these, please?
I'm scrolling too fast.
State machine is icing.
That's on this one would be is async compiling both debug and return.
But presumably the compiler doesn't warn you for shit that generates, right? The last time I looked, they basically don't walk the diagnostics of things that are just generated.
Yes, although the generated things are free to allow to enable nullable. And then
What would be mismatches?
if the generated code enables nullable in the generated file, then we'll start warning.
Sure. But these are not like CS generated, right? They're just
No, they're just that's for like WPF.
That exception
generators
doesn't handle. It rejects null exception. Async method builder of key result. You give it string question mark, it can accept a string. If you give it string with no question mark, it doesn't accept a string, so that seems fine.
That's really only have one L.
That's a discussion. There's like yes and no, it depends on where.
The standard we've adopted is cancel, canceling, canceller, cancelable all have one L. Cancellation has two.
Oh.
Which I believe is the American Heritage Dictionary version.
Yeah.
It just doesn't look right to me.
Yeah. Well.
Anyway.
Welcome to English.
Where things make sense unless they don't.
So they just don't.
But there was no API review for the English language, so what do you expect? Things are inconsistent.
I blame German.
Oh, German is not better, man. Everything is regulated, but doesn't mean that the result is consistent.
English was fine when it was Latin. Then we mixed in German. Then it got weird.
Oh, it's French, so that's not helping your case.
Right, so the exceptions, I assume we're just doing the representation that you could have called any of the constructors, so all the properties can be default.
That's generally what we did for exceptions. Pretty much everything in the repass to exceptions is nullable.
Because it'd be really sad if throw new abandoned mutex exception through an argument null exception.
It would be hilarious.
It would.
What's as funny as the compiler non-roughing when it does the nullability analysis, which I've seen, which is actually quite funny.
We
Anyway,
dog food in null. In the nullable walker and found several bugs. Great.
then you removed it because you found all the bugs, right? So what happens if I pass in a null action and then I ask for the value? I just get default of fee.
Where are you?
Async local.
Well, so the value doesn't constrain to the hand, right? That's for when it's changed.
Yeah.
So when you call set,
Oh, I see.
it will potentially call that thing.
Never mind. Not a factory.
Carrier constructor, I assume, is just a forwarder. Null means see the other guy.
Barrier is one of those classes almost never used.
Which one?
Barrier.
Yeah.
I've never used it before.
Creates a memory barrier. Like, well, everybody has to hit it. Then people do it. Synchronization primitive.
Runtime intrinsics SSE dot load fence, store fence, and memory fence are also great primitives to use.
Can I make an advertisement where you when we shoot like 5-minute videos of you where you advertise various intrinsic features?
Things that you could do with existing like other APIs, but no, you want to use the intrinsic.
So I know. So I looked just now just to make sure it matched. So on cancellation token source create link token source of params, it does reject the null array from params. Is that a thing we do? A thing that we like that we do? I think it's consistent.
We pretty much always throw if a params array is null.
Yeah,
Okay.
I always thought we don't, but apparently we do. Yeah.
Okay.
It is definitely a thing that we do. I can clearly.
Well, I'm looking at one example, right? One does not make a pattern. So,
Yeah, but like if you look around, like pretty much everything that takes params, I checked it at some point. Everything is non-nullable.
Okay.
It surprised me too, but
I'm just.
what is a compress stack?
It's no one uses it. It's basically legacy from CAS days.
Oh, it's the runtime stack. Yeah. And like a stack that doesn't have push and pop seems weird.
You give it null, it calls you with null.
Yeah.
Execution context capture returns null.
If you've suppressed execution context flow.
Okay.
Did you just realize that your code has a fuck ton of bugs? It's a bit concerned that run does not allow now.
Sorry, where are you looking?
Like it seems like you want run to basically when you pass it in an execution context just does nothing.
Oh, well, that might be nice. It will throw.
The host execution context manager, the previous stage should.
I mean, the easy workaround is if execution context is null, just invoke the callback. Don't send it back into the execution context.
Because that seems like a very
Sorry, Christoph, what was your question?
If the host execution context manager, then if they revert to the previous normal.
No, if you pass in null, it'll throw. In fact, if you don't pass in a switcher, there's some other type, like a host execution context switcher or something. If you don't pass in one of those, it'll throw as well.
Yep. Object must be a host execution context switcher. Which is a private class. So this is give me back the thing I gave you.
Interlocked. Yep, that makes sense.
The CompareExchange is not solution.
And this is the one where, well, I'm not sure if it'll happen or not, but we've asked that if the compiler can special case CompareExchange and enforce some, and provide some nullability rules around it that we just can't express in code.
The return is not null as long as the first two values are not null.
Right. That's one of the, there's like two main cases that it could relatively easily do. That's one of them.
And just and string question mark matches class question mark. Does string also match class question mark?
String matches class
Yes.
question mark, yes.
Okay.
They're asking whether you can instantiate this of a non-nullability.
With both kinds of string, yeah. How does inference work with nullability?
It works exactly the same as before, and if there are mismatches, then we won.
Well, so if in CompareExchange, because I forget how, if inference is the first argument or all of them, if the parameter passed into value was string question mark, but the field was string.
Yeah, so the inverse is actually more common, Jeremy, but what you're getting at happens. So if you generally will have a field that's nullable because it starts out as null.
Right.
And the value you pass in will be non-null. The inference there warns you.
Yes.
Okay.
If the field is non-null and the value is null, yes, that should work.
No, the opposite. Generally, the field is nullable. So the first argument ends up being a ref to a nullable field, and the second argument ends up being a non-null value, like it's new object or something, ends up being the second argument. And so the compiler ends up seeing a T question mark and a T.
And it picks T question mark because that was the first parameter?
It warns.
Yeah, I'm...
At least in my experience thus far, it has warned in Corlo. Because the reason I asked for CompareExchange to be special cases, we hit this in a ton of places because CompareExchange is used for a lot of lazy initialization.
Great for that, yeah.
But maybe there was an issue and the compiler has changed or fixed how it was doing inference, which would be great.
I'm checking.
I'm still confused what the warning is, though.
Because if it picks string question mark, the value should implicitly go from non-nullable to nullable.
Right, which should never be a warning, right? I can always call something that accepts a nullable with a thing that is provably non-nullable.
Yeah.
Why would that ever warn?
I think it was always picking. Maybe it was always picking the non-null one, or I don't remember exactly.
Maybe it's the return that you complain about, because the return will always be non-null. Will always be non-null, right?
I think the issue Steve mentioned, I think it was there like not in the beginning, and I think they fixed it later. But I'm
Is it?
No, I think
it's the first, because I know it ends up with. I don't remember if inference, what the current inference rules are.
Can we
Find
just check
the
it
most
quickly?
specific.
I'm checking it. Yes.
Yeah, I would definitely expect if the first parameter string question mark that the return string question mark. And
No, I think I know what the problem is. I think the problem is once you call the method, the compiler doesn't know that based on your arguments, location is definitely not nullable.
It's possible the inference was fixed. I just tried it, and it appears to.
I think the problem is you always have to, like, after you call CompareExchange, you know that location 1 is initialized, right? But like the compiler doesn't know that. I think that's your problem. You always have to still bang the shit away afterwards.
I think the issue was actually was related. It was that there was an issue with the compiler implicitly treating, allowing you to pass a string question mark to something that took a ref. Allowing you to pass by ref a string question mark to something that took a ref string, which it should be allowable, but for a while it wasn't.
Oh,
and
I see.
Okay.
I see.
And I think that was what the issue was.
Okay.
I see.
But location is only guaranteed to be non-null if comprehended, and value is not.
Right. But that's the common pattern that you have.
Yes.
The compiler doesn't know that, so you.
And then location 1 after is also guaranteed to be not null if value 1 was. If value was not null.
Yes.
And
CompareExchange will only swap in value if location 1 was comparand. So if comparand and value are both non-null, you don't know what location 1 looks like. I guess you do. It's either one of them. It's one of those two.
Yeah, it's definitely not null.
So, yes. If one of them is guaranteed non-null, then the output's guaranteed non-null. Yeah. Okay. Ooh.
it's a little complicated, which is why we're trying to possibly do special cases instead of trying to create attributes to express this.
Indeed.
But yeah, you can do
Nullability would be made easier on this if we added interlock.compare null or CompareExchange null and just got rid of comparand. You'd be able to reason about it better.
Yeah, I'm curious, like, how many times you call CompareExchange with a non-null comparison? It is not that common, I'm pretty sure.
It's actually so there are two scenarios that you often use CompareExchange for, and null ends up being super common in one case and not particularly common in the other. So for lazy initialization, you pretty much always have null. For reference types, you pretty much always have null as the comparand. But the other thing you use CompareExchange for is like updating a value in a thread-safe way, substituting it in. So you read the current value, you manipulate it in some way, and then you pass in the previously read value as the comparand. And if you fail, you try again. Yeah. Like, if you were building a concurrent stack or something like that, where you needed to allocate a new node and swap it in for the next pointer. And so in those situations, comparand is often not null.
Yeah, that makes sense.
Or you could have a sentinel value that is not null for purposes of answering questions. Then once you've added state to it, you have to swap it out.
Does Exchange have a not null if not null?
Probably would have.
Exchange does on both the result and the ref.
Okay.
Is this the thing where you can't show both attributes or you have to choose the attributes or the diff in the viewer right now?
Right. Yes, but also like I don't think attributes are completed, which is why we haven't done this yet. Do another pass on the attribute. Ensure initialized.
Ensure initialized takes a null sync lock.
Yeah, in this overload, it basically allows you. So this overload does double-checked locking, and it will handle initializing the lock for you if it hasn't been allocated. So if there isn't, there should be an attribute on the ref object sync lock that is not null. So basically, when this method returns, sync lock will not be null.
Right.
What
I thought I put that in, but it's possible I missed that.
Well, we don't have attribute showing in the view right now.
I see.
And
is that basically the plumbing that we use for lazy of t? So it looks like T is a bunch of statics.
I don't remember if we actually use it internally or not.
and the
So it looks like we're actually missing attribute.
one more question then on ensure initialize the target. Is this ever not null? The target of an ensure initialized ever not null? Because currently T is constrained to be class, not class question. We don't allow
Right. So for the first overload you're talking about?
the last overload, but also the first overload.
So
Yes. I was looking at the last, but the first also works.
So both of those already had class constraints. We didn't change that. So you were already constrained to using a reference type.
Right, but
for the first one, we use activate or create instance under the covers. So you will never get back non-null.
That's
right,
the
but so the ref should the ref allow null in? Is my question.
Yeah.
It does. There's an allow null attribute on it.
Oh, okay, perfect.
Okay.
That answers my question.
So, but then wouldn't that just be ref t question mark, or is allow null different than ref t question mark?
Yes, because allow null only is talking about the input. We're saying that the output is definitely not null.
Gotcha.
If I remember, before you move on, Emo, I had. I'm trying to remember what the issue was. I had some concerns around the last one, and it was. Oh no, never mind. I was concerned that there would be issues, I think, with the value factory returning null, but I believe I checked the implementation and it throws if you return null. Right, move on. But Emo, did you catch that there should be a not null attribute on that last overload?
I don't.
And also that.
We should write this down, but the thing is, we need to make a pass the attribute. But the attributes were not complete last time. I think there was one in the middle that we viewed with attributes, but for the most part, we haven't really looked at the attributes.
Oh, okay.
So that's why I haven't paid attention to attributes.
Got it.
Did you fix the issue with API?
I have not done anything like that. But given that it's the last review today, I think for this week, we're going to be fine. Lock recursion. I guess that makes sense. So the mutex can have a nullable name? Does it have no name for mutex?
Oh, yeah, that's required for the name.
Doesn't that just forward to create mutex in the Win APIs?
Yeah.
Does that allow null?
Thought so.
Yeah, I thought mutexes have to have names, but I might be wrong.
No, if LP name is null, mutex object is created without a name.
Alright then.
Or does it give it?
I mean, that's so. I didn't know that it works this way for C#, but I did know it worked this way for Java, so it doesn't surprise me.
And we call those anonymous mutexes.
Yeah, they're terrible. Just like anonymous threads.
Just remember, the name is limited to max path characters.
I wonder why there is.
Enable long path.
I don't know if that works.
Maybe you can pass the name with the parser. What does it mean to do overlap and not having a completion callback? Does fire and forget?
I guess.
Fire and maybe I'll check eventually.
How would you know?
You just guess. I think
Um,
0.5 seconds has been long enough.
Actually, question. So the overlap constructor takes a non-null async result, but the property returns a nullable async result.
I guess that's when you call the first constructor.
Yeah, because I would think that if it's valid to set it to be null, turn null, that the constructor would be allowed to take null.
Well, I guess the question is, what do the other parameters mean if you don't have an async result? Maybe they only make sense.
Probably the same thing as if you set them manually and then set async result to null.
Yeah, I think
that's fair.
Could check. It's probably that the last argument to the constructor should probably be nullable.
I mean, this is the first issue of interesting.
Yes, well, we don't check for it to be null, non-null, and we just store it into a field where it allows it to be null.
Yeah.
Right? Sense?
However, the setter for that field doesn't accept null.
Setter for async?
No, it does. It does.
Yeah, I was gonna say.
Why is the field nullable when it looks like we always assign it?
Well, I mean, it will no longer be the case if you change the constructor, right?
No. Sorry. All of those parameters are stored in an overlapped data field, which we have marked to be nullable.
Oh.
But it looks like every constructor always sets overlap data.
Because free sets it to null.
Ah, okay. Seems like maybe a bool would be better in that case, but.
Well, given that it's a field, it's more like what do you find more convenient when you also the type, right?
It seems like it should have been not considered nullable because we just bang away the warning and we don't check anywhere.
Yeah.
So.
Yeah, it seems like
we should just put the bang in the one case instead of the 10.
Right.
Yeah, that's a good point. If all the patterns always bang it away, then what's the point?
Anyway.
You don't write a lot. You can find right out.
Nobody should use this one. Everybody should use this one. And rapidly.
What does it mean to unregister a null weight object? Do we just return false?
It's not that you're unregistering a null weight object. The weight object is signaled when the unregistration completes.
So we would just signal nothing.
Right.
Okay.
Man, this brings back memories. Last time I walked this namespace was Windows 8. If you use them well, they're amazing. If you use them wrong, not so much. It's probably true for almost everything in here.
Synchronization is hard. Sender post callback, is that a class or
it's a delegate? Sender post callback is a delegate.
Delegate, okay. We don't accept a null callback there then?
Correct.
Well, the whole point of this is that you are called when it's posted, right?
I don't know.
We have done crazier things.
Man, that's a lot, yeah. You don't have a generic modifier? I guess you don't, because they're all constrained by.
Not on thread. There's one on volatile.
Oh, I see. Yeah, that's the new S. That's right. This is the old API.
Hold on. The sender. Go back up. Thread exception event handler. Senders. I thought we said senders were allowed to be null.
So where do you see this?
The delegate thread exception
That
event
one.
handler.
Go down.
There.
I think it depends on. We could make it nullable. I'm not sure it would affect anyone. But I think we had said that it would depend on who was expected to invoke the delegate.
Yeah, I wrote a general rule that says events should accept a null sender, but we can revisit this. But we should probably have like a rule of thumb for this. But yeah, like the specialized delegates probably. I mean, the question is what would the default event handler do, right? And that's probably we can't actually we can't express it because it's always typed as object.
Yeah, I don't even know where this is used. Like, is it used anywhere?
I don't find any references in source of .NET.
No, it's basically the unhandled thread exception, I think. Isn't that on app domain? You have no.
Oh, it's Windows Forms.
Yeah, that makes sense. That's what it does. Yeah, I think it was. Yeah. It was always weird, but yeah. I think in this case it's probably the application instance would be my guess that you get. So it's probably always guaranteed to be non-null.
Yeah, we're at least in desktop. Just looking at the few callers there, it's always called with thread.current. Thread is the sender.
Oh, thread is the sender. I guess that makes sense too.
But I mean, if we want to have a policy, I don't know that it would hurt.
Yeah, I mean, if you consider the normal coding pattern, right? Given that sender is always typed as object statically, you always have to cast, right? And you probably should always do a try cast. You never do a hard cast, so you always have to compare to null anyway. So in which case, why would you care?
Yeah, that's true. We could say they're always nullable.
Yeah.
Thread local.
The only interesting thing with thread local is we're not reviewing attributes, but there's going to be a maybe null attribute on value.
What does it mean for the delegate? We have no way to annotate the delegate, right?
Sorry, which delegate?
Like the function we pass in, we have no way of.
Oh yeah, you mean like to attribute t in some way?
Yeah.
No. But the main thing is that when you access value on a thread where the value has not yet been set, you'll get back default of t if there wasn't a delegate provided.
So if you basically just have a new thread local of t and then didn't provide anything, then
No, with thread local of t, you'll often have a static one or something.
Right.
Or you'll have an instance, and then you access that from any thread, and you say, like, what is that thread local dot value, and that's based on the current thread you're accessing it from. And so if I'm on a new thread that I've never accessed it on before, its value will be null. Well, will be default of T.
Yeah, only when you use the first two constructors, right? I would think.
Correct.
Yeah. What does track all values mean?
It means, let's say you have you create a thread and you set a value into the thread local on that thread, like some disposable object or something, or some critical resource, and then that thread ends and goes away. Do you want the thread local dot values property, the one that returns a list of T, to include the thread local from that dead thread or not?
Interesting.
So if you were, for example, if you were doing a like an aggregation and you had 100 different threads that at some point came and went as part of the aggregation, summing up something, you would want to track all values, because at the end, if you then iterated through the dot values property and only contained values from the 10 threads that are currently still alive,
yeah,
you'd be missing out on data.
That makes sense. Yep, they look we would expect. Yeah, unsafe queue user work item probably would also have a low null for the T state, right?
What was the question, Nemo? So I can hear.
This one here would probably also have the low null for T state then, right?
Well, no, that one, I mean, if you've made your T state nullable, then you could pass in a null.
Oh, that's it. Yeah, I keep forgetting it. Yep, never mind.
Generics are hard.
Yep. Here's my read with T.
Will Bright have a attribute that disallow null on location?
Why would it?
Well, because you cannot write on a null location.
Well, it's a ref, right?
Yeah.
Oh, okay.
For refs, you cannot express that. And he does not ref if you do that. I have to fabricate one. Task cancel. Oh my god, I can't believe we're still this.
Is it done?
That is system training, yeah.
Seems like there's
You would think that, but if I scroll there, all I do is I shift the text to the top. This is how the VS editor behaves. If you scroll all of this, I get a blank page. Huh?
And do you have any items for 10 minutes?
I don't think we have something for 10 minutes.
We have lunch.
Yes,
I
lunch
think
seems very
there's,
good.
I think there's a small one. So, I think system threading
Santi.
overlap or system threading.
Unless you already have the DLL on disk, it's not going to happen.
I have it there.
All right.
We want lunch.
And we're gonna get done with nullable.
So which one do you want?
There's one that is small. I think is system threading overlapped.
We'll do the timer one, for example.
Overlapped is pretty small, right, Steve?
Yeah, I mean, you see the size
Yeah,
here,
overlapped
right?
as well.
I mean, you don't have to guess. Only we have the indicator for the size.
Oh yeah. So timer and all.
Yeah, that'd be insane, wouldn't it? If we had some indicator for the size of the DLL.
Am I making fun of us right now?
Nope. Never.
All right, so this is before, so let's try what was it, the timer one? So,
Yeah.
This is the problem with Windows. Always in the wrong place.
I told you it was super small. This was one class.
All right.
We can make it.
I don't know, guys. There are no generics here. What can I find to argue about?
I sync disposable.
Oh, that's it.
Nope, looks good to me.
Yep. What were we saying about one type per assembly?
Shut up. It's two types. It's two types. Two types you can do. One is where I draw the line.
I'm telling you, it's a distribution. As you get further out, the lower number of types per second you get.
That's what this export is.
Then you've got outliers, where you're further down the stack, but the number of types goes up.
I'll talk about it.
Yeah, they make people question my sanity.
Specifically emo.
Well, what can I say? When people do funny things. All right. All right.
So the same question about the IO sync result probably.
Yeah,
This is the same. The overlaps here is the same type we just reviewed.
Yep. Oh. It's type forwarded or?
I believe it's type forwarded, or it might not even be exposed. I'm not sure why it was showing up. I have no idea why it's showing up in both places. There's only one of them.
It should not. It should not be type forwarded. Like, I think that might be a bug in Santi's reference assembly.
well,
Because we don't follow type forwards in the review tool.
that makes it.
But it would show up on the diff as a new, right?
Oh, let me do a quick check. Super assembly. Assembly info. And hopefully this doesn't crash. And then
Did something change with a microphone being used? I basically can't hear emo at all.
because maybe depending on whether I speak towards the microphone or not.
Ah, Yeah, I can hear you.
Or the fact that Imo's laptop's about to take off.
Yeah, that's probably because I'm sitting behind my laptop. I'm the only one of the laptop.
Oh, that's what all that background noise is. It sounded like you were driving.
I mean, his computer was driving.
Yeah, so I don't know why it showed up in system threading. I just look at my reference assemblies and overlap this only on system threading.
Yeah, it might actually be that it's type forwarded. I mean, it probably is type forwarded, but it should not show up. I don't know why it shows up.
And it does on both sides. That's probably a bottleneck. I was just two going. But it does.
Oh, there's another issue. We have to send it twice? No. Yeah, this is a problem with code, right? Code tends to rot. All this used to work at some point. Then things change. Anyway, so here we are. Thread pool bound handle, whatever that means.
It doesn't seem to be type forward.
Well, that would be bad.
So when are we getting nullable annotations for pointers? We can make another pass.
I don't think anybody cares about that.
You're using a pointer, so it could be null.
Basically, if you're using pointers, you're supposed to know what you're doing.
In C++, as the
Yeah, tell C++
feature.
with their nullable annotations.
Wait, are they seriously planning on doing this?
I mean, Clang and MSVC both have built-in support for nullable annotations. And the Windows headers are full of them.
I mean, so those are SAL, I guess, right?
Yeah, but
Probably
it's still
you
nullable
imported
annotations.
both assemblies.
that are
system
enforced by the
threading,
compiler.
No, I thought that, but like it might be that it actually resolves that. As I said, it might actually be. Like, it should not follow the type forwards. Yeah, I think, but like apparently it does.
Clang actually has an API for
Which is
nullable, is not nullable.
Yeah, I guess maybe it does. Anyway, all right. So then, any concerns with this one? Otherwise, you mark this as good as well.
Yeah.
And then
Ship it.
And then we go get lunch.
Yep.
All right. So, what else can we look at?
We have 3 more to go for system threading.
So we did-
Thread pool is small as well.
Yeah,
it's the
let's do
same-
thread pool.
Yeah.
I need to leave at 1 yet. I need to go get lunch.
Yeah, you can have lunch.
Plenty of time.
Just not yet.
It's not a good sign. It's lunch exception.
It's the lunch exception. Lunch not observed exception. All right.
States can be null, callbacks can't.
Wait handle can't be null. That makes sense. Otherwise, what are you waiting for? Wait or timer callback.
I think
Does
we
that
already take a look at this one.
What? No, I don't think we looked at that.
No, yeah, because you asked about the unregistered and registered one time.
Oh, that's right. I asked about this one. Yeah, I think this probably also type forward, would be my guess.
Okay. Is it resolving? All of those are in the same.
Yeah, I think
folder?
I think that's why I'm confused. Yeah, I think it does. I think they're just facades. And this also explains why they're so small. Because they're just type forward. All
Back
right.
when we thought 100 assemblies was a good idea.
So then, thread pool we have done. So the only one left is tasks now. Might as well just do tasks.
And maybe we already did it.
We already did test.
Well, there's still like
We already did task? Yes, we already did task.
Let's see.
Yeah, we already did it.
I think these are all the ones. They're just type forwarded. Yeah.
Great.
All right. So then we're done with threading. All right. Then thanks online and see you later at some point.
See you later, Steve.